Hello and welcome. In this video, I want to provide a demonstration of the solution to our previous challenge. Basically a solution to a program written in C that will print the perimeter and area of a rectangle. So I'm going to start code blocks up, and I'm going to first create a new project. I'm going to get a meaningful name. I think I'm going to name it rectangle, and it's going to be put inside of our regular directory path. I can create a new project by just going up to File, New, Project. I'm going to select a console application. That means it's just output to the console, to the screen. It's not a graphical application or anything. I'm going to hit go. I'm going to select C, standard stuff. I'm going to name this project rectangle. It's going to create a project file for me. It's going to put it in my usual download area. I'm going to hit next, and I'm going to create debug and release configurations. And I'm going to say finish. This is going to auto-generate a C source file for me called main.c. I'm going to go ahead and use this. All this does is put templated code in there to print out some information. I don't need to do that. I am going to keep the two standard includes. I could add comments at the top of the file. This is good practice. For this demonstration, I'm not necessarily going to do it. But if I want to add a multi-line comment, I would just put in, my author, typical things, author. And I'll do it, I guess, for learning purposes here. Author, purpose. This program is going to calculate the area of a rectangle. And then I could put in the date as well. But I want to end that multi-line comment with an asterisk /. You'll see my two include directives here on lines 5 and 6. I'm including the standard IO for input output because I want to use the printf function. Standard libraries also includes because it has other important stuff in there, but we may not use it. So this program is going to calculate the area. And I mentioned in the requirements that we need to create some variables. In order to create variables, we have to specify the data type, and we also specify the name of the variable. And then we also may want to initialize them. We need to create variables for the width and the height, and they should be of type double. So the way that we do that is we just say double. That's a data type. We say name of our variable. We want to get a meaningful name, so we're just going to say double width for our first one. And we're going to initialize that to some value, anything we want. We're going to say 32.5, 32.3. We're going to end it with a semicolon. We're going to create another variable for the height. Here we're going to set another value to it. The way that we can assign values to variables is using this equals operator. That's assigning a value to a variable. Here we'll just say 15.2 or 3. Now remember, we could create these variables on the same line actually, but we can't initialize them on the same line. I could put a comma here and say height, but they won't be initialized both to that value. I would have to initialize them on another line. So I'm just going to create both variables on separate lines and assign them, initialize them on the same line as well. I could override these later and actually assign different values if I wanted. But I created my two variables. I also have to create variables for my perimeter and area. Now I don't know what these are going to be equal to yet because they're going to be calculated. So I'm just going to create these and I'm going to initialize them to 0. And we could say 0.0 since it's a double. The same with the area. I'm going to also initialize this to 0.0. It's always good habit to initialize all of your variables. Now that we have our variables, we have to actually do our calculations. We haven't learned fully how to use operators yet, but it's very easy to do mathematical equations operators in a program. You use the traditional operators that you would use in any math class. In this case, I want to assign values to perimeter for a calculation. So I'm going to say perimeter, and I'm going to assign it using the equal symbol, and I'm just going to say the perimeter is going to be equal to 2.0 times, using the asterisk, and then in parentheses, because I want to have precedence, I'm just going to say height plus width. And then I'm going to end that statement with a semicolon. That's assigning new data to our perimeter variable. Mainly 32.3 times 32.3 plus 15.3 times 2. And I'm going to assign area equal to the width times the height. That's how you calculate the area of a rectangle. Use the asterisk for multiplication, and you just specify the variable names. So width and height are variables that we want to multiply. The last thing I want to do in my program is I want to display this output to see if it's correct. I can use the printf function to display output. And when I want to display the value of variables, I have to provide format specifiers. But remember the printf function first takes this first argument. Anything inside double quotes will be displayed to the screen. So here I just want to say, and we could print out all three variables, or we could just print out the perimeter. Let's say perimeter is, and then after the is, I want to print out the value of the variable, so I have to use a format specifier. We can use a format specifier by doing a percent symbol. After the percent, we have to specify the type of the data. Here we're displaying doubles, which are floats, so we can say %f. And then the data that we want to display has to be separated by a comma, and then the name. Here, we just want to display the perimeter. And I have trouble spelling perimeter. Then we want to end it with a semicolon. We also want to display the area, so we're going to use printf again. Inside here, we're just going to say area is, and again, we're going to say %f for a variable, and then we're going to have the comma, and we're going to say area. And this is basically the program. Now, you'll definitely want to make changes, do different things. And the last line here, we're returning 0. We'll explain that later when we talk about functions. But for now, just know it's standard. So now I'm going to hit Control S, or I'm going to save all. I'm going to go up and build this. Hopefully there will be no compile errors. There isn't. Now I'm going to run it. The one thing that I didn't add were line feeds, so it's going to be difficult to read this. So let me use an escape sequence to say \n. After I print out perimeter is, I want to add a line feed. Remember, escape sequences are actions that are interpreted by the compiler to do something, and they're represented through these weird character sequences. In this case, \n represents a line feed. \t would represent a tab. So let's resave it, build it again. And this time let's run it, and the output should be formatted a bit better. So when we run it, what we're going to see here is perimeter is 95.20000, area is 494.19000. And that's these two calculations. And it looks correct because 2 times 32 plus 15.3, that would be 2 times 47.6, which is 95.2. So that's correct. Width times height would be 32.3 times 15.3. I can't do that in my head. But if I put out a calculator, I'm sure it would be 494.19000. You also notice they're printed on separate lines because we use the \n, and they're formatted nicely. Now, say I want to print out more than one value of a variable. Say I want to print out width and height. I can say perimeter is, and I can actually add more format specifiers. I can actually say, let's first say width is, and then add a format specifier for the width, and then put a comma, and then say height is, and then put a format specifier. So for each %f, we have to have a comma outside of the double quotes to represent that variable. So the first %f is going to be a width, so that has to be my first one. The second one is going to be the height. The third one is going to be perimeter. So hopefully this makes sense. See what I did here? I'm printing out multiple variables on a single printf. And so you can put multiple %. They just get mapped to whatever the commas are. So %f is going to be mapped to width, the first %f. The second %f is going to be mapped to height. The third one is going to be mapped to perimeter. And now again, I save this and I build it. And for output, we should now see, in addition to perimeter being displayed, also the width and the height. So when I run this, we'll see that the width is displayed as 32.3000, height is 15.3000, perimeter is 95.2. So we printed 3 variables. Maybe we want to get rid of some of those zeros. We could actually add in %2, .2 I think it is, .2, %.2f to format it to 2 decimal spots. Let's see if this will work. I always forget the syntax. This might be incorrect actually. Let's see. So let's see what this does. The height and the width, I want it to be more precise. Compiled, so let's see if it runs. And when I run it, it actually displays 32.30, 15.30, because I specified %2.2f. That's only displaying it to 2 decimal points. So you can play around with these format specifiers. And this is the basics, right? We created some variables. We defined the data types for those variables. We assigned data values to them using the equal symbol. Did some calculations and displayed the output. Now, if we were getting really ambitious, we could actually, instead of hard coding these to 32.3, we could add in some parameters to our int and pass data. And then, we'd have to do something like this. And we'd have to actually assign what was ever passed in. We'd actually convert it to a double, and it would be we'd have to do something like this actually. Convert it to a double first. But this is kind of getting more advanced for what we're learning here. But this would actually take in two parameters and assign them. So it'd be a little different. We'd have to then select our project, and we'd have to set the program arguments. Here we could just specify them being as like 44 and 28. Now let's see what happens here. Now when we build and we run, it should use 44 and 28 as for our calculations. And it does use 44 and 28, and it does a different calculation there. But that's getting ahead of ourselves. Let's just not use program arguments, but you can verify that's how to do it, and just assign hard-coded values to whatever we want again. And I'll provide this source and zip file to you so you can take a look at the source code if you're confused. We should also probably be providing single line comments in here. We could say something like declaring variables. Again, comments are nice because they help document the code. We could say performing perimeter calculation, and then the last one could be displaying output. Again, a lot of this is intuitive, but if somebody's completely new, they might get confused, so you provide the comments. So a lot of things that, again, we focused on here. Hopefully this helped with your understanding of variables, data types, using printf to display variables, format specifiers, and escape sequences. Thank you.